Now let us see the properties of determinants. Now these properties are extremely useful in evaluating the determinant, because many times it's not required to evaluate the determinant as per the method as we have seen earlier, but it is mere application of one of these properties will simplify the calculation. Now the first property says that if some row or some column of a determinant contains all zeros, then the value of the determinant is 0. Secondly, if any two rows or any two columns of a determinant are identical, then the value of the determinant is 0. So basically first two properties indicate a shortcut or a quick check on how can we conclude if a determinant is having value as 0. Now moving on, the third property says if some row or say some column of a determinant is multiplied by some constant k, then the value of the determinant also gets multiplied by k. Now here it is evident that whether it is multiplication or division, basically the value of the determinant also gets proportionately affected. So let us move on to further properties. Now the next properties talk about in which situation the value of the determinant will remain unchanged. So that is the next property about, that is property number 4. Now here we see that if rows and columns of a determinant are exchanged, then the value of the determinant remains unchanged. That is, even if we write rows as columns and columns as rows and evaluate, we will still get the same value. The next property says if some multiple of elements of a row or a column is added to the corresponding elements of another row or another column, then the value of the determinant still remains unchanged. So as an example here, this notation says that R1, which means the row 1, that is first row, is changed to R1 plus 2R2. So what does it mean is we are basically multiplying the elements of second row by 2, and that product we are adding to the elements of row 1. So in that case the resultant determinant will have the same value as the original determinant. Now here it's important to note that when we say that we are multiplying the elements of second row by 2, we are actually not modifying the second row. It is only the product we are adding to the first row. So therefore it is only first row that is getting modified. Now another important point, as we have seen, as these properties say, that is whatever property is applicable to a row, the same is applicable to a column also. But it's just that we should not mix up rows with columns. So if we are applying a property on a row, then we have to apply it on a row only. Otherwise we can apply it on any other column also, but not both together. Now let's move ahead and see another very special property of the determinant. Which is property number 6. Now that property talks about the way in which we can break up a determinant into two different determinants. So here if some row or say some column of a determinant is expressed as addition of two elements or two values, then the determinant also can be expressed as an addition of two determinants. So here it is shown, like if you observe that the first row consists of 3 elements which are expressed as additions of the two values each. So therefore we have a plus b into or rather the other element is c plus d, and the last element is e plus f. So if we have this particular case, then we can write the determinant on left hand side as the sum of two determinants as shown here. Now if you observe, the way to break is, in the first row of the first determinant, we write any three of the elements, that is out of A and B we pick up A. Then from the next two elements, that is C plus D, suppose we pick up to write C, and from the last two elements, that is E plus F, we choose to write E. So therefore A, C and E make the first row of the first determinant on right hand side. So therefore the remaining elements, which are nothing but B, D and F, they become the first row of the second determinant. Now it's not mandatory that as we have shown here, that all the first elements of the particular addition are to be written in the first determinant. We may choose to do in other way also, that is say for example, it may happen that we want to write A, then D and then F as the first row of the first determinant. Therefore the first row of the other determinant will become B, C and E. So therefore it is just the way of splitting the two determinants. Now as far as the other two rows are considered, we can see that they remain unchanged. So row number 2 and row number 3 remain unaffected in both of the determinants on right hand side. Now based on this, we will see some of the examples of how these properties can be efficiently used to reduce the calculations and get the answer directly.